Ladies and gentlemen, you join a very, very proud Catz today. You know, Obi-Wan Kenobi was super proud of Luke Skywalker. Dumbledore was super, super proud of Harry Potter. And I'm very proud of Senator Jared Rennick. Every great teacher is proud of their great students. And Senator Jared Rennick has come to my channel. He's learned something and he's applying it in the Australian Senate. I need to fill you in with this story if you haven't seen it. There are videos just posted in the last week or two on this channel which you can go and watch. But if you just want the quick refresh, you can get that now. I made a video not so long ago, 2 weeks ago, and I called it Senator Completely Fails at Science, where Senator Jared Rennick was in the Australian Senate talking to a professional scientist about climate change. And he was trying to undermine the current understanding of climate change. And he did it through basically this word salad here. Let's have a listen to what he's got to say.
Right, so first law of thermodynamics, or the equivalent of third law of Newton's law of motion: for every action there's an equal and opposite reaction. So assuming carbon dioxide, and it's not, but assuming it's the same weight as N2O2, how can one atom of CO2 heat up 10,000 other atoms of N2O2 through conduction?
Now, there was a lot of scientific words there, not used perhaps necessarily in the right order or an order that even made sense. And I did pick him up on that in my video. And Senator Jared Rennick responded. He wrote me an essay. Here's the essay. Now, I made a video about the essay he sent me to correct him on the mistakes he'd made in the essay. And I thought that would be that. But little did I know that I was going to stumble across a video of him again talking in the Australian Senate, putting into practice the information, the knowledge bombs I had dropped upon him. He was putting them into practice in the Australian Senate. I'm very, very, very proud. We're going to look at how he's progressed in his knowledge, and we're also going to look at some other areas in which he can continue to progress. I know he's going to come back and watch this. Senator, again, you are more than welcome on the channel. I'm so stoked we're building up this kind of relationship where, you know, almost like this teacher-student, master-padawan kind of relationship. I'm very, very proud, very, very proud of you. So, one of the things he told me in his comment was, Einstein himself says that radiation is so insignificant, it drops out in his 1917 quantum theory of radiation paper. Now, what he meant by that was he was trying to say that when heat is spread through the atmosphere, it's not spread by radiation at all. He's saying Einstein said that wasn't a thing. So what I actually had to do is actually read Einstein's paper. I don't think the good senator had actually read it himself. And I found the section that he was a little bit concerned about. And I explained to Senator Rennick that Einstein didn't say radiation drops out at all. What he said was, compared to other processes such as particles of collision, etc., it's okay to talk about energy transfers without mentioning radiation, because compared to those other processes, it's a very, very small exchange of energy due to radiation. So it's not that it was insignificant or just drops out. It just compared to other processes, it's a lot smaller. So, did he apply that knowledge in the Australian Senate? Let's find out.
Senator Rennick.
My question is to the Minister representing the Minister for Industry and Science, Senator Farrell. In his 1917 paper on the quantum theory of radiation, Einstein said
Order.
The energy transferred by radiation is so small that it always drops out as compared to other processes.
Get in, Senator. Now, I know that might only be a small thing. It's gonna get better from here, though. But you know, it's this little attention to detail that I'm just a massive fan of. I couldn't be prouder of what I've seen there. It's making me well up. You know, I'm getting quite emotional. Oh, that's the best Christmas present. Anyway, what else did he tell me? This was a real doozer, this one. He said to me, an electron is 1,800 times lighter than a photon. He told me 1,800 times lighter than a photon. Now, that is completely wrong. A photon we will consider to be massless, really just negligible mass compared to an electron. But I did correct him and say that an electron is actually around about 1,800 times lighter than a proton, which obviously they're locked away in the nucleus. Did he take that misunderstanding learn from it, and apply it in the Australian Senate? Let's find out.
Given the mass of an electron is 1,800 times smaller than a proton.
Get in! He did it! He did it! Now, I don't actually understand what point he thinks he's trying to make with that. I mean, here he told me it was 1,800 times lighter than a photon. And I understand, that when energy, when photons are absorbed, it is electron excitation that occurs. And then when de-excitation occurs, I can't speak, I'm so excited, then radiation is emitted in the form of photons. It doesn't really have anything to do with protons. I'm not sure why he's mentioned that, but we can see the progress that's happening. Now, I'm super stoked. I'm super proud. I don't really, I don't want to go on to the next part of the video where I've got to pick him up where he gets other things wrong, but it's part of the growth mindset. We celebrate the wins and then we target future improvement. So I'm glad you listened, but let's look at other places that you can continue to improve, Senator.
How can a photon absorbed by an electron in a carbon dioxide molecule at a wavelength of 14.8 microns, an energy of 1.4 to the power of negative 20 joules, be expected to increase the temperature of the surrounding 6,600 nitrogen and oxygen molecules by 1 degree without violating the first law of thermodynamics?
I mean, it's a beautiful question. What we're going to do is we're just going to take advantage of the subtitles and we are going to bob back a little bit. And Senator, I know that you have this growth mindset. I know that you have this will, this drive to educate yourself. So let's do that. How can a photon, so he's talking about a single photon here, absorbed by an electron in a carbon dioxide molecule, be expected to increase the temperature of the surrounding 6,600 nitrogen and oxygen molecules, violating the first law of thermodynamics. Now, let's not get bogged down in the mechanism about heat is transferred through the atmosphere just yet. And let's just get to the nitty-gritty. How can a photon? Now, what I'd like to tell you, Senator, is that carbon dioxide molecules in the air don't absorb one photon, and that is it. That is the cause for the atmosphere increase in temperature. What happens is they emit energy in the form of photons. Sorry, they absorb energy in the form of photons. They emit that energy. And then you know what? They absorb more photons. They absorb photons and they emit them. Then they absorb more and they emit them. So maybe you have this strawman idea in your head that they are just absorbing a single photon and then emitting some energy and poof, magic greenhouse effect. The atmosphere has got a little bit warmer. That's not how it happens. It's like a continual stream of energy in the form of photons and a continual stream out. I do hope that's helped. So when I watch one of your future videos, I'm really looking forward to you adding that to your repertoire and starting to talk about like a continual process rather than a stop-start, one photon in, one photon out, boom, global warming and greenhouse effect. I know you can do it. I'm rooting for you. My subscribers are rooting for you. Make me proud. Anyway, that was the first thing I wanted to pick him up on. I'm not going to go overboard. Last time I did it, the video lasted half an hour, and it was truly boring. So let's just pick him up maybe on one or two more things that he can perhaps learn from. This is another question he asks later on.
Carbon dioxide has 4 frequencies that absorb photons.
Well, we'll stop there. Carbon dioxide has 4 frequencies that absorb photons. If we're going to perhaps go to a Senate hearing, make the effort to write out a question so we can read from it, maybe we should write the words of that question in an order that makes more sense. Maybe you're trying to say carbon dioxide absorbs photons of 4 different frequencies. Saying this...
First supplementary.
Carbon dioxide has 4 frequencies that...
Carbon dioxide has 4 frequencies that absorbs photons. That's what we call meaningless word salad. So, just one more time. Carbon dioxide will absorb photons at 4 different frequencies, is the question you were trying to ask. Now, it's not actually true. I mean, it absorbs maybe it absorbs many different frequencies that we can group into 4 main bands, which we can see here. So they are bands that contain, lots and lots of different frequencies. But I kind of get where you're going with that ish. Took me and my team of translators a while to get there, but we got there. Anyway, let's listen to his question in full. We'll answer it, and then we'll wait for him to apply it in the Australian Senate.
Carbon dioxide has 4 frequencies that absorb photons. One incoming infrared band at 2.8 microns, one non-polar at 4.3 microns.
I was muted. I don't know what you mean when you say a non-polar frequency. That's something that we would call, what's the word? Nonsensical garbage. So maybe 2 words. A frequency is a measure of, it's the number of oscillations per second, or the number of waves that will pass a point in a certain amount of time. It's a measure of how often something occurs. Saying a non-polar frequency makes no sense. Maybe you're getting a little bit confused that carbon dioxide is a linear molecule. It's not a polar molecule. I'm not sure why that will make any sense in terms of what you're trying to say here. But yeah, maybe don't refer to frequencies as being non-polar in the future.
And 2 outgoing long-wave bands at 14.8 microns. Planck's law states that the energy of a wavelength is inversely proportional to its frequency, meaning that CO2 absorbs incoming photons with 5 times more energy than the outgoing photons it absorbs. Why is this cooling by CO2 overlooked by climate alarmists?
Oof, well, there's a lot to unpack there. Essentially, you are wrong, Senator Rennick, and I will explain why you're wrong, and I know that you'll take this and move on. So the argument he's making is that the carbon dioxide molecules are capable of absorbing higher frequency photons, which essentially contain more energy, and they emit lower frequency photons, obviously, which contain less energy. And he is under the misconception that this applies some kind of cooling effect to the atmosphere. What he's not necessarily stating is he talking about incoming photons that are coming from the sun towards the Earth's surface, or photons that have been emitted from the Earth's surface into space? That is important. Whoa, what's happened there? Look at that. So if we use this little graphic, the energy that is passing through the atmosphere and being absorbed by Earth does consist of these higher energy photons. And when they are re-emitted by the Earth and go back into space, they are of lower energy. That is true. And the carbon dioxide molecules will absorb these lower energy photons and then re-emit them in all directions, including back towards the Earth. And what this means is energy is now making it to space at a much lower rate than it is being absorbed by the Earth. And therefore, the energy in the system increases and we get global warming. Now, if he's claiming that the carbon dioxide absorbs higher energy photons, if we're talking about the outgoing photons, well, that is the problem. That they are absorbing this radiation and not allowing it to go into space. They are absorbing it and then re-emitting it back into the system. So it doesn't really matter what frequencies they're absorbing and then re-emitting, because whatever frequencies they are reducing the rate at which that energy goes back into space. So I can only think he's talking about the incoming photons, and he's under the misconception that the carbon dioxide molecules are going to actually absorb more energy that's coming towards the Earth, because they absorb these higher frequency photons. Well, the problem that he's got, and I put this in my members video, is although he's not wrong that they will absorb high energy photons as well as low energy photons, when we look at the graph here, I'll just blow this up to full screen. I put this in my members version of the response to him. We can see this little graph, and it shows a little bit more clearly these bands of frequencies that carbon dioxide will absorb, but also the kind of affinity, the absorption coefficient, if you like, but the affinity of them to absorb those frequencies. And these higher frequencies here that we can see I'm hovering over, we can see that they barely absorb that. They do absorb them, but compared to these lower frequencies, you know, the difference is absolutely huge. It's not equivalent. So we cannot say, because they absorb these higher frequencies here just a little bit, that will have any kind of cooling effect on the atmosphere at all, when obviously the lower frequencies here are absorbed by you know, much greater amount at a much greater rate. So, you know, Senator, you've taken some of the stuff I've taught you and you've applied it. I'm so proud. I really could cry. I really could. And I just, you know, I want you to take this other little bit of advice that I've given you today, and I want to see you apply that, and together we will grow. We will grow and improve together. I'm a massive fan of your work, and you know, I just love this team up. So thank you so much. Goodbye.